This is the Building Automation Monthly Podcast with Phil Zito, episode 92. Hey folks, Phil Zito here, and welcome to episode 92 of the Building Automation Monthly Podcast. And in this episode, I'm going to be discussing preventative maintenance for building automation systems. Now, you may be thinking to yourself, what? Preventative maintenance for building automation systems? What does that even look like? And, if you're thinking that, you're not the only one. I used to think that too, because, when you think about preventative maintenance, right, it's pretty easy when you're sitting there thinking of HVAC and you're like, oh, preventative maintenance for HVAC. Well, yeah, you go and tighten belts, you go and lubricate bearings, you go replace filters, you go and clean out strainers for your coils. That's all pretty obvious stuff, but if someone were to ask you, what is preventative maintenance for building automation systems? What would you say? After all, it's all software and, direct digital controllers and things like that. So, what maintenance is there really to do? And I think that's where a lot of folks get stuck, is they fall into one of two camps. They fall into a camp of, hey, this is software. I don't have to do anything. And I firmly believe that a lot of operators, a lot of facilities folks, they want to do the right thing, but no one's ever sat down and kind of talked to them about what they can even do with a building automation system. And so they just kind of struggle. What can they do? And then I think on the flip side is, okay, but how much is enough? How much is too much? What should I focus in on? So the whole purpose of this episode is to take a collection of ideas around preventative maintenance and kind of explore each one of those ideas. There's no specific order to the items we're going to cover here. I haven't chunked them into categories. I'm just going to go based off the top of mind ideas that I've written down here on a piece of paper. And we're just going to explore each one, talk about what it means, kind of the thought behind it, how you would do it, and what I want you to come out of this episode with. Here's how I'll judge if this episode's a success. Is I want you to come out of this episode with a different thought process when you look at your building automation system. I want you to leave with the thought process of, what could I be doing that by doing it will have a really large effect on both the current state of my building automation system as well as the future state of my building automation system. So, for example, the first thing I have on here is backing up databases. Well, right now, if you were to go back up your databases, that would have a huge effect because a lot of our programming, a lot of our set points, a lot of our graphics, a lot of everything we use is kept in a database. And if you don't have a copy of that database, if something were to happen to your BAS, you could potentially lose hundreds of thousands of dollars of work. And I don't think people ever really stop to think about that. We kind of just take it for granted that our building automation system is just this thing that we can run 20, 30 years and it'll never fail. We don't stop to think about, oh, well, what if, someone accidentally uploads instead of downloading a database? Or what if somehow a database gets corrupted? Or what if somehow our server gets corrupted and we lose all our graphics? We lose all our set points. What kind of potential damage does that have to your building automation system? Because the reality is I've read a lot of specifications, and very, very rarely is any redundancy built into projects. It's usually, how can we get a BAS in here for the lowest price humanly possible, short of, using baling wire and, 2 cans and a piece of string? And how can we get this system in here for dirt cheap? So that's kind of how I want you to come out of this podcast. I want you to just be absorbing this information. Just kind of absorb it, listen to this episode a couple times, and I think you'll take some really valuable information out of this episode. And I'd love to hear your comments in the comment section about, what kind of ideas do you have around preventative maintenance? All right, let's dive in. So I already told you what item number 1 is, right? And that's backing up databases. So a lot of folks tend to think that databases are just trend logs, alarms, override reports, etc. But they're much more than that. See, here's the deal. And I'm going to go a little techie nerdy on you real quick, but I promise it'll be short and not very painful. So what happens is you've got this software, right? And this software has these properties in them, and these properties can be set to certain values. So for example, your room temp set point can be set to a certain value, and that value resides sometimes in the controller, but more often it resides on the server or supervisory device. Well, if the database that exists in either of those devices were to get corrupted and failed, then when it were to reboot, it would not have that set point and you would lose that set point. Now, extrapolate this to all of your balancing set points, all of your K factors, all these things. Now, on some of the newer BASs, this isn't as much of a big of a deal, but on the older BASs, this is definitely a huge deal. This is a very big deal that you need to be concerned about. And so when I start to think about the first kind of preventative maintenance action you should take, you should definitely come up with a regular schedule to back up your databases. For me, I usually have the general rule of having a backup every time something major changes. So if I do a retrofit or I do some major, retro commissioning or some adding of devices, those kind of things, I'm going to do a backup. And then I'm going to number my backups so that way I know which one is the newest. You would be shocked how many folks make backups but don't ever number the backups, and then they're trying to figure out which backup is the most recent. And that is not a situation you should be in. So next up is tuning PI loops. Now, I've done whole episodes on tuning PI loops. And this seems to be a hot topic for a lot of folks. And you notice I'm using the term PI loops and not PID loops. And I know this is going to rub some of you the wrong way. And honestly, I don't really care. But in all seriousness, there's not a whole lot of scenarios you should be using PID loops. They just add all sorts of variables and problems that you really don't need to be dealing with. I mean, let's face it, PID loops are meant for process control. They're meant for predictive reactions. If you understand what you're doing, 9 times out of 10, your PI loops are going to be just fine. I mean, we're not talking nanosecond loops. We're not talking microsecond loops. We're talking 1-second loops. And what do I mean by that when I say 1-second loop? Well, the time it takes your controller to run through all the functions on the controller, all the code, that usually is about a second. And then the loop refreshes itself. So we're not talking where if you're using a nanosecond loop, so many loop cycles are happening before you ever get to a second that you need that derivative capability. Now, if you're like, what the heck are you talking about, Phil? PI, derivative, all that stuff. Basically, what a PI loop is, it looks at the difference proportionally between your commanded value or your set point, like what you're trying to achieve, and where you're actually at, and then it commands an output. So it looks at zone temp and zone temp set point and then commands a damper proportionally. And then you have integral, which looks at how long have you been away from set point, and then it adds some value. Otherwise, you could get stuck in this position where you never go higher than the proportional response. And then derivative essentially is supposed to oppose integral, and it's basically a way of balancing it all out. But it just adds confusion. It makes it really hard to troubleshoot, and it adds a variable that's unnecessary. Now, I know I'm going to get some flames, and some folks are going to be like, Phil, why aren't you talking about PID loops? You're shortchanging everyone. Okay, whatever. Anyways, for those of you who live in reality land, PI loops are really where 99% of your focus should be. Because let's face it, most folks don't know how to program in the first place. And for them to try to go even beyond PI loops and go into PID loops it's just a mess waiting to happen. So focus on the things that are going to get you 95% of the way there, and you will just be so much better by doing that. Just, this is something that I always I struggle with because I'm not a perfectionist. I'm someone who believes in the philosophy of get 90, 95% and get it done versus strive for 100% and never get anything done. And so that's why I'm teaching you. Focus on a PI loop. Now, okay, now that I'm off that soapbox, what do I mean by tuning PI loops? Well, in an ideal world, you would use state-based control. That means you would go and say, hey, when I'm in cooling mode, I have a cooling PI loop. When I'm in heating mode, I have a heating PI loop. When I'm in free cooling mode, I have a free cooling PI loop. But the reality is that a lot of folks just have one PI loop and they use like a stop of 50, and then from 50 to 0 is 0 to 100%. And from 50 to 100 is 0 to 100%. And if you're like, Phil, you're just totally losing me on this. Basically what they're doing is they're scaling the output. If the output of a PI loop is 50, then that's a 0. And for cooling responses, you're going to go from 50 to 100% output equals 0 to 100% command. And for heating, you would do from 50 to 0 would equal 0 to 100% heating command. Well, that's all well and good until you're stuck in a cooling mode and yet you don't have cooling enabled because for some reason the chillers just aren't on yet due to outside air lockout or whatever. And so your loop gets all wound up. And in these cases, and you see this a lot in older controls, you don't see this so much in newer controls. Pretty much all the new controls use state-based programming. But in older controls, you definitely see PI loop wind up, which basically you start to go and your I, which is that integral piece, you didn't set an I max on it. So basically you just keep adding until the output's 400, 4,000%, and you just have a mess on your hands. So if you're in that boat where you don't have state-based control or you don't have I max limited on your PI loops, then you definitely want to go and do PI loop tuning. Like I said, we'll go a little geeky in this episode, so if some of you folks are like, oh my gosh, no, stop, technical stuff, painful, don't worry. I'll go a little geeky every now and then, but pretty much all this stuff, if you're a manager, if you're in sales, is still going to be applicable because these are things that you can either add to your scope of service contracts, or you can make sure that your techs, if you're a manager managing techs, you can make sure that they are going and implementing these. And if you're like an energy analyst or you're someone who's doing evaluations for energy savings, then these are things you can look at for your energy conservation measures. All right, next up is calibrating sensors. So this is a really important one, right? Sensors, whether you like it or not, they tend to drift over time. And, it depends on the sensor type. So you have resistive sensors and you have element sensors. I know, yes, there are many more sensor types than that. There's flow sensors and all sorts of other stuff. But the main ones that we deal with as far as tuning goes and calibration are resistive sensors and element sensors. So resistive sensors, essentially, you have essentially a type of metal, nickel or platinum are typically the two, and they change state based on temperature. The resistance changes based on temperature. And essentially what you do is you look at a resistance chart and you see how much off the temperature sensor is. And if it's too much off, then you're going to replace it. But if it's just a little bit off, what you're going to do is you're going to go and you're going to do calibration. And so this is something I see, especially in a lot of older buildings, is that they've got sensors they've had for 10, 20 years. and they're 3-4 degrees off. And when you're controlling a system to 3 to 4 degrees, and maybe it's a 30,000 CFM system, or maybe it's a 400 GPM system, and you're controlling a temperature, that's a huge volume of BTUs, of energy, that you're controlling to that you don't need to. That you may either be subcooling too much, or you may be going, all right, where was I? My 6-year-old came down. She's fighting a nasty cold, and she was crying, and so I had to go get her some medicine. But I think I was talking about the fact that BTUs that get wasted based on temperatures when they aren't calibrated. You see, what happens is that if you're reading, for example, 58 degrees when it's actually 54, and you're going and trying to drive to a 55-degree discharge on a 30,000 CFM air handler, that can waste a ton of energy. And so with that, you really got to dial in these things. So this is something you should be doing at least, once a year, to just make sure that these sensors are calibrated. And granted, you don't have to do this on every unit. You don't have to go to every VAV box temp sensor and be like, oh, I got to calibrate it. But at least on your big units, there's no reason why on your chilled water and on your major air handlers, you're not going and calibrating sensors. That's just pure laziness. That, or you just didn't know you had to do it, which, some of you are going to love this episode. Some of you are going to hate this episode, because after this episode, you need to do this stuff now. So, it's just really important. But then there's another thing that kind of piggybacks on top of this topic, and it's verifying control device operations. You really want to make sure, and I chuckle because this seems so obvious. I want to make sure my control devices operate. But, I think you would be shocked how many major hospitals and universities have entire buildings that they think are operating and aren't. I remember this one university building where folks complained during the summer it would just be so hot. And what they didn't realize is that one of their major air handlers, it had the outside air damper 100% open all the time, no matter what. And so it was bringing in this super hot air, and the air handler just could not chill the air down enough. And if any of you know about how all basically air handling units and things like that work, is that what happens is you return air, and this air in the ideal world, it's not heating up that much, and you're able to cool it down, right? But when you're going and bringing 100% outdoor air in, and that air is 90 degrees, you're just not able to cool that down, and you start this vicious cycle where you're not able to remove the heat from the building, and it just starts to get really, really hot. So you definitely want to verify your damper actuators, that they're operating, your valve actuators, your fan relays. All the different devices that you could go and control. You want to make sure they're working. Now, you may be thinking to yourself, well, yeah, but the mechanics check that. Not really. Sometimes they check that, but honestly, most of the time they're doing their basic maintenance checks. Are the filters good? Are the fan belts good? Are the bearings good? Are the coils good? But they're often not checking the automated control devices. And so for you, you can't assume that the mechanics are going to go and check those. They might. They very well might. But chances are they probably aren't. And so you really need to stay on top of those. Another huge one is adjusting schedules. One of the quickest ways to go and save energy in an existing building is to just reset all the schedules. Now, you may be saying, well, Phil, what do you mean by that? Well, imagine this, right? So I was working with this major Fortune 100 organization, and I won't name who they are out of respect for them, but they came and they were like, man, I really wish that we knew to go and check our schedules and really have a way to tie back to occupancy, because they had 3 buildings for years that were running 24/7 and no one was in the buildings. Now, I know this is probably hard for you to believe, and some of you are like, nah, Phil, that's not real. I'm telling you, this was the exact words from the facility director for this campus. That was his exact words were, man, I wish we had integrated access control into our BAS so we could see that no one ever accessed the buildings and we wouldn't have had these 24/7 schedules running. But here's the deal. Here's how this happens, right? It doesn't all happen at once. So you have a Christmas party, or you have some sort of after hours event at the school. And you go and, you schedule the BAS on for that day. And then what happens is let's say that's Thursday. Then Thursday now, the new schedule for Thursday becomes from 6 a.m. to 9 p.m. every Thursday. Because oftentimes what happens is folks will not just make a single schedule, they'll just change the existing Thursday schedule. Because maybe they just don't have the rights to go and do temp schedules, maybe they don't understand, maybe they're just in a rush, but they change the existing schedule. And you have a couple months where this happens, and before you know it, you have these schedules that were once maybe 6 to 3 or 6 to 4. And now they're 6 to 10, 6 to midnight. And pretty soon, you essentially get to the point where you have 24-hour schedules almost running on your buildings. And that's why I say one of the quickest hit form of energy. Forget demand control ventilation. Forget optimal start. Forget resets. Forget pressure resets. Just go and make sure the schedules are accurate to the zones they're serving. I mean, I would argue on probably half the buildings I've been involved in, you would see massive return just in doing that. And if you do see massive return, I definitely do accept checks and PayPal for that advice. And you can just send them to buildingautomationmonthly.com. I'd love that. No, but in all seriousness, it's really good advice. You really should take advantage of that. I think for a lot of you, you'll be shocked if you dig into your schedules. Okay, so then next up, kind of following along with that, is control overrides or operator overrides, and just basically clearing those out. And this kind of ties into a later tip that I was going to go with, and it's basically doing operator override reports. And this is something you should be doing every single week. You should go and be checking for operator overrides, verifying with whoever overrid the system that override's still needed. Because the last thing you want to do is someone has something overridden because they're performing maintenance, and you're like, oh, I'm going to release the override. And next thing you know, you cause some havoc. But this one little tip ties into so many design considerations. For one, you need to make sure that everyone is using a unique login. That way you know who actually did the override. And when I say using a unique login, it doesn't mean you create unique logins and everyone still uses, HVAC user. But no, you create unique logins and then you enforce that everyone uses a unique login. I mean, that is critically important. And if you don't do that, then you can't go and clear operator overrides. You can't go and really do that because you don't know who did the operator override and you don't know if you're going to cause problems. So it's really important. Clearing operator overrides, that will have tremendous effects, kind of akin to scheduling. You look at scheduling, you look at operator overrides, and you can see some massive return just from doing those changes. So another one that folks often don't think of is alarm tuning. You hear PI loop tuning all the time. You're like, oh, you gotta tune those PI loops. But you don't hear folks talk about alarm tuning. And how often is this the case? You get a specification to implement a BAS at a new building, and it's, set the alarm to 5585. And that's it. They don't say, well, the occupied or the unoccupied modes or whatever. It's just a broad number. Well, here's the problem with that. For one, when everything is the exact same priority and everything is the exact same range, nothing becomes important. And that's how you get alarm fatigue. That's how you get these major sites that have 40, 50,000 unacknowledged alarms, and their alarm management strategy is to just hit Control key plus A for select all and then delete all their alarms, once every 3 days. And that's how, I was at one site where they had a central plant that was down for 30 minutes because they missed the central plant alarm. I mean, that's kind of funny, but at the same time, it's not funny because it's like, oh my goodness, this was a high-tech site, and what potential damage could that have done, losing their chiller for 30 minutes? I mean, that's ridiculous. But that's the reality where a lot of folks are. So alarm tuning is quite simple. You go in, you look at your alarms. Once again, start at your largest units and work your way down. But you go and you look at your alarms and you say, okay, is this range reasonable? Is it reasonable to think that an 85-degree discharge air temp on a unit that uses steam heat or electric heat or whatever, and I'm going to say, hey, that I'm going to have a discharge air temp of only 85? I mean, that may not be reasonable. You may have a discharge air temp of much higher than that. Or you have a discharge air temp with no heat, and you're going and saying, hey, I'm going to have a discharge air temp alarm of 85. Well, if you hit 85, something's really, really wrong. So maybe you want to go 75. Maybe you want to go 70. You can always tighten down, or you can always expand alarm ranges. I mean, you got to use your better judgment on these kind of things. But going and looking at this, you're really able to tune things down. You see, whenever you get a specification or a design, it's general rules. It's general setup. It's like going and buying a generic Ford Mustang, and it's going to be all right. It's going to be a nice car, but, when you actually take it to the shop and you tune it to be how you want it, and you go and you can make it faster, you can make it handle better, you do a variety of different things. Well, it's the same with a BAS, right? You're going to get a generically designed BAS, even with good specifiers, and you've got to go and kind of make that thing fit how you operate. And it's really important that you do that, but a lot of folks go and miss out on those things. So I think we'll do one more tip here, and this is going to roll into episode 93. I don't see any way that it doesn't, because I've still got about a dozen more of these tips here, and we're coming right up on the 30-minute mark. And I try to be respectful, keep it at that 30-minute mark, because that's about the amount of time that each one of you is going to be in the car typically. And I want you to be able to consume this and then immediately be able to apply it right when you show up on the job site. So the final one that I'm going to go is adherence to naming standards. This one is a personal pet peeve of mine. You go on these sites and every site has a different naming standard. So like this one site has 3 buildings. One building is room temp, the other one is zone temp, the other one is space temp. And, it's different for each freaking building. And it's like, oh my gosh, shoot me, please. This is, you can't imagine how someone who doesn't have the advanced BAS training you have is able to even operate this, because they go to a building and everything's different. They can't do queries because do they query zone temp? Do they query space temp? And the thing is that one of the things you should be doing as an operator, as a BAS designer, as a specifier, as a salesperson, whatever your role, you should be driving towards naming standards. Naming standards are going to make the lives of everyone so much easier because you're going to immediately know what something means. But let's say you do that. Let's say you get naming standards all set up and everything's well and good. And then one day, you're out on vacation and a controller fails. And so Bob goes and he installs a new controller, but he just does whatever names he wants to do. And what happens is you don't notice it. You don't really, it's down in the minutia. You don't really see it. And before you know it, this happens a couple times over a year or two, and your naming standards are just shot to crap. You've got, templated graphics that are expecting a certain name. That way they can go and discover that point. And all of a sudden you've got all these unbound references and data points that are unreliable because you're not following that standard. Plus, your folks who are operating, they don't know what to do because the points they're looking for don't exist, or at least in their mind they don't exist. Now, I know some of you are like, but come on, Phil, people got to think for themselves. They got to look at space temp. They got to look at zone temp, right? Well, today, when I'm recording this, I took my daughter to a basketball game, and as I was leaving, I was taking her to this burger place called Culver's, and I was like, I want to get a cheeseburger, and I want it plain. And so then we get down the road, we've left, and she opens her cheeseburger, but it has no cheese. And I look at the receipt, and it says cheeseburger plain, no cheese. And I'm thinking to myself, like, oh my gosh, are you serious? Like, it reminds me, I was this little kid and I went to the grocery store and I ordered a cheeseburger and I said, I just want meat and cheese only. And then I open up the box and there's no bun. It's just meat and cheese. And you got to understand that a lot of folks, they're in just this mode and they just take things literally. And so if you go and you have things that are space temp, room temp, zone temp, they're not going to be able to pull themselves out of autopilot and see what's going on. So you really got to get focused on that naming standards. All right. So we've covered a ton in this episode, a ton of very actionable tips that, the beauty of this being a podcast, you can go and listen to this again if you're driving and you can make sure that you jot this stuff down. But you can immediately apply these things on job sites. You can immediately apply these things to your facility teams. You can immediately apply these things on energy projects and you will see great results. So with that being said, when you're listening to this, if you're listening to this when it came out, it is the week of Thanksgiving. And coming up on Thursday, I actually have my one and only ever Black Friday sale. I'm never going to do this again. I'm only doing this because I just started taking Building Automation Monthly full-time. I resigned from my role at Johnson Controls, and I'm taking this full-time, and I'm looking to just get a cash influx. So what I'm doing is I'm taking my courses that normally cost $2,000 each, and I'm discounting them by 50%. So for a limited time, you'll be able to pick up my courses for $1,000 instead of $2,000. Now, I'm never, ever, ever going to do this again. I'm only doing this once, and this is your chance to take advantage of this coming Thursday. So I encourage you to pay attention. You'll see this if you're on Facebook or LinkedIn, or if you're on my mailing list, you'll see information about this. So really important. In some other news going on, I'm going to be speaking at the ASHRAE Winter Expo. I'm actually going to be teaching Building Automation Systems 101. So if you're going to be at the ASHRAE Expo, be sure to stop in, check it out. I'd love to meet you after my speech And I'd love to just spend some time meeting you, shaking your hand, getting to know you, asking you questions, answering any questions I can answer for you. That would be absolutely awesome. I love to help folks and be great to meet some of y'all in person. Also, if you are in Europe in March, I believe it's March, maybe it's February, I'm going to be speaking at the Smart Buildings Conference 2018, where I'm going to be teaching the future of information technology for BAS professionals. Basically, how can you learn IT and what do you need to learn? So I'd love to see you at that conference if you're over in Europe. That will be really exciting. And what else? What else is going on in the life of Phil Zito? I've been, when you're listening to this, I've been doing Building Automation Monthly for 2 weeks now. If you're listening to this in the future, it may be a lot longer for that than right now, where it's just 2 weeks when I'm recording this. But, I've learned a ton from this. It's kind of crazy. You don't know what you know until you go and you leave and you get out on your own. And it's like, oh my gosh, all these things I wish I'd done beforehand. All these things I wish I'd known. It's kind of crazy because I've been talking to some major manufacturers and they're talking about how they're bringing their training online and certain folks are going to be doing certain really cool things. And I just think we're in a really cool time right now because it used to be that you're at the mercy of just working, 10, 20, 30 years and just learning through osmosis. And hopefully you got with someone who was willing to share and you just picked up whatever. But now with the internet, you're able to just learn almost like instantly, like Matrix, like where you jack in and you just figure things out. And so I'm super duper excited to be doing courses online. But what I'm really excited about on top of that is I'm going to be starting a live YouTube TV show. And basically, I haven't decided yet if it's going to be Tuesday or Wednesday. But check out my YouTube channel, and I'll link to that in the show notes at buildingautomationmonthly.com/92. But check out the YouTube channel, and I'm going to start doing this every week where I'm going to hop on live, and I'm going to do a teaching for about 30 minutes or so, and then I'm going to do question and answer for about 20 minutes. And, I think this is going to be really awesome. It's going to be kind of the Building Automation Monthly TV show, and it's either going to be awesome or it's going to be totally crazy, but that's kind of the world I live in. You do things and you figure them out as you go. I think that a lot of you probably need to get more comfortable with that because you kind of stick in roles and you don't challenge yourself to advance because you're afraid of taking a risk. Well, I'm telling you, you take a risk and I can say from experience, it's almost never as bad as you think it's going to be. What else? So we talked about the speaking, we talked about the TV show coming up, we talked about the Black Friday sale. Well, that's about it. I'm just really fortunate that I'm able to spend time talking to each one of you. Thank you so much. A ton of you have reached out to me via email with questions and just congratulations on the move, and I appreciate that more than you know. I mean, you all are why I do this. And I am every day, seriously, every day I'm thankful that I'm able to go and help you all out on your building automation journey. And if there's anything you need, I'm serious, just shoot me an email. And it may take me a couple days to get back to you, but I will get back to you. So thank you so much for listening. And thank you so much for being here. I am having so much fun doing this. And in the next episode, we're going to continue on exploring some of these optimization kind of maintenance strategies for building automation systems. And with that being said, like I usually tell you, everything is available at buildingautomationmonthly.com/92. Once again, that is buildingautomationmonthly.com/92. I look forward to seeing you in the comments. Thanks a ton. Take care, and I'll talk to you again next week.